Now in this lecture we are going to implement delete node method based on the algorithm that we discussed in our previous lecture. So here again we are going to implement this method inside CircularSinglyLinkedLis class. So this means that after search method I'm going to create our delete node method. So I'm going to declare our method like this. Then as a parameter it will take location parameter. So with this parameter we are going to identify which node we want to delete. Now the first thing that I'm going to do, I'm going to check that if head equals to null, then we are going to print out to the console saying that the linked list does not exist. So if condition will be like this, if head equals null, in this case we are printing out to the console saying that the CircularSinglyLinkedLis does not exist. Now after doing so we have to return, because in this case it doesn't make sense to continue to our code. Then if this is not the case, we are going to check the location parameter. So if the location parameter equals to 0, it means that we want to delete an element from the beginning of the CircularSinglyLinkedLis. So I'm going to write our else if condition like this, location equals 0. This means that we want to delete an element from the beginning of the CircularSinglyLinkedLis. So when we are deleting an element from the beginning of the CircularSinglyLinkedLis, we have two cases. So the first case is we have only one element in our CircularSinglyLinkedLis, and the second case is we have more than one element. So if we have more than one element in our CircularSinglyLinkedLis, the first step is we are setting head to reference to second node. So if I set head equals head.next, it's not referencing to the first node, so it's referencing to the second node. Then the next thing is we have to set tail to point to the first node. So in this case we have set that second node is going to be the first node in the head, so I'm going to set tail.next to head. So with this, last node will be referenced to the first node, so we know that in case of CircularSinglyLinkedLis, last node has to point to first node. That's why we are putting tail.next to head. Now the next step is we have to decrease the size by 1, because we have already deleted one element from our CircularSinglyLinkedLis. So this means that the size of this CircularSinglyLinkedLis is decreased. Now here we have implemented the case in which we have more than one element in our linked list. But how can we identify if we had one element in our CircularSinglyLinkedLis? Now here after deletion, if the size becomes 0, it means that we had only one element. So that's why I'm going to write if condition like this. If the size is 0, this means that we have to set tail to null, head next to null, and head to null. So with this, we have successfully deleted an element from the beginning of the CircularSinglyLinkedLis in which we have only one element. Now after doing so, we are going to continue to the next case. So in the next case, we are checking that if location is greater than the size, it means that we want to delete an element from the end of CircularSinglyLinkedLis. Now in this case, I'm going to write else if condition like this, else if location is greater or equal to size. So this means that we want to delete an element from the end of CircularSinglyLinkedLis. Now in this case, the first thing that I'm going to do, I'm going to create temp node and assign head value to it, because we are going to loop through the CircularSinglyLinkedLis until we reach the node which is located before the last node. So in this case, our for loop will be like this: for int I starts from 0 until it reaches the size -1, because we have to go to the element which is before the last node. So that's why I'm putting size -1 over here. Then it will be increased by 1. Then inside this loop, the next thing that I'm going to do, I'm going to set temp node to temp node.next, because in this case, in each iteration we have to go to the next node. Then we are going to check if temp node points to head. This means that this is the only element in our CircularSinglyLinkedLis, so we have to set head, tail, and head next to null. So I'm going to write if condition like this, because currently temp node holds to the node which is located before the last node. So if we have only one element, it means that it will point to the head. So if temp node equals head, this means that we have only one element in our CircularSinglyLinkedLis, so I can write something like this. So before doing so, I need to put head.next equals null also. Then after doing so, we have to return from here, because we don't need to continue to our code. Now otherwise, if we have more than one element in our CircularSinglyLinkedLis, so temp node, which is the node that is located before the last node, has to point to first node, so that's why I'm putting here head, and tail has to point to this node, so temp node and size has to be decreased by 1. So here also I have forgotten to put size decreased by 1 because here also we have deleted an element, so that's why size should be decreased by 1. Now in the else condition, we are going to implement the logic in which we are deleting a node from any given location. So here I'm going to implement the logic like this. In the else condition, one more time, we are going to start to loop through the circle single linked list, but in this case we are going to loop until we reach the location -1. So we are going to loop until we reach the node which is located before the node that we want to delete. So here again I'm going to start from the first node, so that's why I created temp node over here, and which will be assigned to the head. And then for I start from 0 and it continues until location -1. Then here in each step is going to go to the temp node equals temp node dot next. Then when we reach this node, we are going to change the reference of this node to points to the node that is located after the next node. So to do so, I'm going to write like this: temp node dot next equals temp node dot next dot next. So with this, we are setting current node's next reference to the node which is located after the next node. Then at the end, we are going to decrease size by 1. Now with this, we have completed our method. So basically here we have combined all three cases together to delete a node from CircularSinglyLinkedLis. Now let's see how this is working in practice. So here inside this main class, we have created CircularSinglyLinkedLis in which we have only one element. Then I have added 3 more elements to our single linked list. Then by calling traversal method, we have visualized the CircularSinglyLinkedLis that we created over here. So what I'm going to do over here, I'm going to call this method, delete method, for different cases and see that how this is working. For example, for the first case, I'm going to use 0, which will delete from the beginning of the CircularSinglyLinkedLis. Now after deletion, I'm going to print out the CircularSinglyLinkedLis to the console by calling traversal method. Now let's run our code. Now you see that we have an error in our method, so we did an error over here. So here it has to be tail. So if you run our code one more time, you'll see that initially our CircularSinglyLinkedLis was like this. So here we have 4 elements in our CircularSinglyLinkedLis. So the first element is 4. Now after deletion, you see that 4 disappeared in the second print out. So we have successfully deleted 4 from here. For example, if I put something like 8 over here, which is greater than the size of CircularSinglyLinkedLis, and run our code, you will see that last element will be deleted from this CircularSinglyLinkedLis. Now in this case, you see that last element was 7. Now when we are deleting it, last element gets deleted. Now if I do, for example, put over here 1, is going to delete the second element from the CircularSinglyLinkedLis. Now in this case, we know that second element is 6. So you see that 6 gets deleted from the CircularSinglyLinkedLis. Now you see that everything works the way that we want. Now let's see what's the time and space complexity for this method. Now as always, we are going to start from the first line of code. So in the first line of code, we have if condition in which we are checking head value and printing out to the console this message. Now here, this if condition will take O1 time complexity because here we are just checking the head value and printing out to the console this message over here. Now in the next if condition, we are checking location parameter. And after checking that, we are changing the head reference, tail reference, and size. Now this 3 line of code will take O1 time complexity. Now then we have another if condition over here in which we are checking that if the size is 0, then we are setting all references to null. Now in this case, this if condition also will take O1 time complexity. Now then we are continuing to the next if condition in which we are checking that if location is greater or equal to size. Now in this case, initially we are creating a temporary node and assigning head value to it. So this line of code will take O1 time complexity. Then we have loop over here in which we are going to loop until size -1. So if the size of the CircularSinglyLinkedLis is n, so we have to visit all nodes until n-1. So in this case, it's going to take O(n-1) time complexity. So we know that O(n-1) time complexity is also O(n) time complexity. So this loop over here will take O(n) time complexity. Now then, in the if condition, we are checking that if temporary node is equal to head, then in this case, we had only one element in our CircularSinglyLinkedLis. So this means that we are going to set all references to null. So this is taking O(1) time complexity. Now then, after this if condition, we have set temp node's next reference to head and tail to temp node and size decreased by 1. So here also we are doing some basic assignment statements. So this means that this 3 line of code also will take O1 time complexity. Now at the end, in the else condition, we have created a temporary node which will take O1 time complexity. Then we are looping through the circle single linked list until location -1. So this loop also will take On time complexity. Now at the end, we are changing the next reference of the current node to point to the node that is located after the next node. So this will take O1 time complexity, and decreasing size also will take O1 time complexity. Now if we combine all these complexities over here, we are getting On time complexity, because O1 time complexities are non-dominant terms over here. So this means that we can eliminate them. So this will take On time complexity. Now the space complexity is O1 because in this case we are just deleting one element from the circle single linked list. So an extra space is not required over here. That's why space complexity takes O1 space complexity. Now with this we have come to the end of this lecture. So in this lecture we have implemented a logic in which we can delete a node from circle single linked list in 3 cases. So hopefully everything is clear about this method. Now see you in the next lecture.